So let's continue with some more applications of vectors. And here we're talking about velocity, relative velocity at times. An airplane is heading on a bearing of 060 degrees at 200 kilometers per hour. A wind of 75 kilometers per hour is blowing on a bearing of 340 degrees. To the nearest whole number, determine the airplane's velocity and its direction of travel. So that is the resultant velocity, which we are interested in finding. So I have a vector diagram here for you, and let me explain the diagram first. You need to, as a starting point, make this diagram and then solve the question. So when we have heading on a bearing of 060 degrees, that means from north the angle is 60 degrees clockwise. Now the plane is going with a speed of 200 kilometers per hour. That means the arrow should indicate the length of 200 kilometers in your vector diagram. So I'll prefer you to write on a scale and then draw. So here the things are not up to the scale, they're just drawn here to kind of represent the situation. You can look into my video which gives you details of drawing vector diagram. Now, so here OP represents airplane heading on a bearing of 60 degrees. That means from north the angle is 60 degrees and OP represents the length of 200 kilometers per hour. So the magnitude represented by the length OP, and I've written 200 kilometers per hour, and the direction is given as 60 degrees. So that line OP represents airplane. Wind of 75 kilometers per hour is blowing on a bearing of 340. That means you can go from here 340 degrees. That means 20 less than 360, and draw a line which will be representing 75 kilometers, right? So much smaller than 200. So less than half, you can say. So let's say we have this kind of a line here, right? So that represents wind. And so I'll call this velocity of wind, and the direction is at 340 degrees from the north, correct? So if it is 340 degrees from north, that means this angle is how much? 340 minus 270, that gives you 70 degrees. So we have 70 degrees from west, correct? So that's the wind velocity. So in our vector diagram, what do? We put this velocity with tail on the head of the airplane velocity to add them up, correct? So we translate it on this side, putting tail of the wind vector on the head of the plane, right? And so we have this vector here. So PW represents wind velocity, right? It makes an angle of 70 degrees with the horizontal, correct? So here we have. So if you see this point, then the plane makes 30 degrees with the horizontal, alternate angle of 30 degrees. And the wind makes 70 degrees angle with the horizontal. So at this point, total angle included is 30 plus 70, that is 100 degrees. Do you see that? So that is a way to calculate the angle between the two given vectors. Now since the plane is moving along OP and it is pushed by wind from P to W, resultant is OR, right? So we'll call this as VR, resultant velocity of the plane. OR represents the resultant velocity, direction shown by this arrow, and the length indicated by the magnitude, correct? Now the question is, to the nearest whole number, determine airplane's velocity and its direction. So we need to find what is VR magnitude, right? Now you can see if we analyze the triangle OPW, so in this triangle, we know OP is equals to 200, PW is equals to 75, and the angle OPW is equals to 30 plus 70, right, which is 100 degrees, right? So in a triangle, we know two sides and included angle. So whenever we know two sides and included angle, we can use cosine law, right? And find the third side. In this case, third side is the magnitude of our resultant vector, correct? So it is square root of sum of squares of these two, which is 200 square plus 75 square minus 2 times 200 times 75 times cos of angle between them, which is 100 degrees, square root. So that is how we get the resultant velocity. It's a cosine law. We use cos of included angle, right? So that's an easy way to remember. Now use your calculator and then calculate your answer. So it is square root of, within bracket, 200 square plus 75 square minus 2 times 200 times 75 times cos 100. So that gives you, we can write it approximately as equal to 219.6. So when you get your answer, you should check, is it relevant? So it seems to be good enough. 275, and this angle is 100, so it is a bigger angle, so the side has to be more. So resultant has to be higher than 200. So 220 approximately is good enough, and the units are kilometers per hour. So that becomes the magnitude of the velocity. Now we know in this triangle all the three sides and a set of sides with opposite angle. Therefore we can use the sine law. So now use sine law and find the angle. So we will find this angle theta, correct? If we find angle theta, then we can always say that the resultant is along, total was 60 from there to there, 60 minus theta, right? So that becomes our direction for the resultant. So sine law, so put the angle right on the top. Sine theta, will write sine theta, the thing which we need to find. Opposite to that is 75, is equal to known angle of 100. So sine of 100 divided by side opposite, which we just calculated, 219.6, correct? Now from here we can find what theta is. So theta equals to sine inverse of 75 divided by 219.6 times sine of 100 degrees, correct? So when you calculate, it is important to check that degrees are mentioned there, right? You don't put them in radians, right? So angle is in degrees. So do second function, sine inverse, you get within brackets 75 divided by 219.6 times sine 100. So what do you get? So you get approximately angle of 19.7. So that is your theta, 19.7 degrees. Now if this theta is 19.7 degrees, then how much angle does VR make with the north? So from the north, it is 60 minus 19.7, right? So we say bearing angle is, bearing is 60, because this velocity, plane's velocity was 60, right, from north, and it is theta minus 19.7 degrees, right? So that gets you the answer. So it is, you can say, if you take away 20, it is 40. So it is 40.3 degrees. So that becomes the answer. We have to round this to the nearest whole number, right? So we'll round this to 40 degrees. Correct? So that is rounding to whole numbers, and we'll write down now our answer, and our answer rounded to the whole numbers. So velocity, the resultant velocity VR is equal to, rounding this to whole number gives us 220 kilometers per hour at a bearing of 40, we write 040 degrees. So whenever you put bearing angle, you have to put 3 digits. Remember that part, okay? 040 degrees. So that is how you should do this question and write answer very clearly. I hope you understand and appreciate it. Steps to do it is first show your vector diagram and then use cosine law to find the resultant velocity magnitude, and then sine law to find the angle. Remember, the angle which you calculate is not your answer. You have to really find the bearing angle. As we did here, 60 minus theta gave us the answer, right? And then write your answer very clearly. I hope you understand and appreciate it. Thanks and all the best.